Hi everyone. I once did some work for our former DG, Professor David Rind, and he told me, he said at conferences, he said, you don't actually have to be very good when you address a conference. You just have to be better than the person who came before you. So I was disappointed to see Andrew do so well. I think he should go back to revising in his bedroom for 50 hours a week. Anyway, so I'm a geographer, and I thought I'd start with a map. You know, geographers like maps. And this is maybe my favourite map, or a variation of it. And it's health deciles and wealth deciles in Sheffield. And if you don't know Sheffield, you'll know hopefully one thing about it. It was a steel town, and that probably meant pollution. So the prevailing winds mattered, and the prevailing winds come from the southwest. And also into the southwest of Sheffield, there's some nice landscapes. So the rich folk lived there, and the poor folk settled around the pits and the coal areas. And if you look at Sheffield today, you can still see that wealth plays an important role in health. So this is a map where the darker the area, the worse you report your health in a census. And the greener the area, the wealthier you are in terms of income decile. So I think maps can tell a good narrative. I think they're often, you know, a picture is worth 1,000 words, and a map's a good picture. So that's my starter for 10. I think when you look at maps, it's important to look at your own house. That's normally what happens when I go and talk to someone. I say, I'm from the Ordnance Survey. And they say, oh, can you bring my house up? And then being the Ordnance Survey, their next comment is, oh, that's not right. So I thought I'd get this one out of the way and start with a view of my house. Here it is. And I thought I'd first of all let you know that, you know, I live here in this bit, and I've got some addressing data on the left and some maps in the background. And what I thought I'd draw your attention to is Ordnance Survey's data has this thing called, I refer to it as explicit geography. So if you were to look at that map, you could see that there was some geography sort of portrayed as we viewed it. But I can look at it and I can say, there's something explicit about that geography, i.e. we know where something is. We can use coordinate reference systems and we can use other things to say, here we are, we know where this stuff is. So then we can attach to that geography whatever we like. So in the instances of that map, you hopefully remembered seeing some green dots, which represented addresses. And so there's some street address information and a point, which lets me know something. And then there was some map polygons, and the polygons sort of had things about them that we used to color code and make the maps look nice. So there were buildings, or there were streams, or some other stuff. So Ordnance Survey data has a lot of explicit geography, and lots of other people's data has implicit geography. And I'll give you an example of implicit geography. It's something like an address. You kind of know an address is geographical information, but it doesn't tell you where it is in coordinate terms. It just says, in this case, this is something that says, I'm 76 Orchards Way, and then there's a bit of a payload. There's something about it. It might be the council tax records. It may be referencing to schools and their performance, or in the case of this land registry data here, it may be sales information. So there's a lot of what I would call geography that doesn't have explicit geography. And so I thought I'd start by saying one of the things about data and data quality that really, really matters when you're using it is when you try and make a relationship between data that has geography implicitly and data has the geography explicitly. And you can do this through a process called address matching, and lots of people do quite a lot of this. And you maybe don't think about address matching too much. It's probably not something you're all sitting there every day thinking, how can I make my address matching work a little bit better? Or how can I make my referencing work a little bit better? But this sort of matters, this address matching stuff. I mean, if you were to, for example, want to switch your energy supplier, and you rang up and you said, I'd like to switch your energy supplier, 7 times in 1,000, which is quite a large proportion, you'll switch your neighbour. Because the relationship between the point of reference that they have, the MPAN, the meter point reference number, and the address hasn't been well matched, it goes wrong, and therefore you run into a muddle when you try and do something. So 7 people in 1,000 have their energy switched inadvertently by a neighbour. I call that bad data quality. I don't know about you. That's not an outcome I'd like. So lots of things happen with address matching that sort of make sense. But if you do it right, if you do something useful, you can then start to use a lot of data, a range of other data in the context of geography, which we all quite like. So here, and this is that other thing that there was another point I wanted to make actually about this. This is some data I got sent. I do a role at Ordnance Survey where I help people use our mapping, and I do a lot of work for them to make it work. And this is someone from NHS Digital Services wants to be able to target services in areas where he deems there to be greater need. And one of the ways he wanted to do that was through council tax bandings. So he asked me if I could geocode council tax data. So the other thing about data I talk about is access to it. In this case, he didn't just get the data from Valuation Office. He sort of wrote something to scrape it from their website. And I'm not quite sure about the legitimacy of doing that, but I did the work for him anyway. Ordnance Survey data is hidden behind a paywall. It's something I've sort of forgotten because I use it so much. If you're in here, if you're an academic, if you work for government, you don't have to think about that either. The data has open use for you. But if you worked for Amazon or someone else, you would sign a check if you wanted to use the data. And the government is looking at methods to make our data open under use constraints for SMEs, and that's hopefully something that will happen. But I have read stories where people have said, I'd love to do something with land registry data and look at overseas ownership, or I'd love to do something else, and I can't because the data sits behind a paywall. So I'll say up front, there's another issue with data. Good data costs a lot to maintain. If you're a company or an organization that puts data as an output, you're trying to understand how to extract some cost recovery when you do that. I think there's something that says I need to be able to access and use this data because if I can do so much more with it. Council tax bans on themselves aren't very exciting, but I think, personally, I would say that, because I geocoded this data, geocoding council tax banding allows me to understand something about the city I live in and which bits of it maybe did need some additional service provision and which bits of it probably would have issues. And when I start to combine that data with other data, I can perhaps do some other things that are quite interesting. So one of the ways in which people use mapping is they try and use it to aggregate data. They say, I'm doing something where I may be geocoding something. This is another example of some geocoding. This is me geocoding the land registry price paid data, which is one of my preferred open data sets. It's useful and good stuff, and we all like to know how much our neighbours spent buying a house, especially if it's somewhat like our own. So you can get this data and people do some things with it, and they can geocode it. Again, very useful. But one of the things I've kind of discovered with using data is actually all the hooks that make it more useful. And I become really interested in the ONS data, and I become really interested in aggregation. And I think when you aggregate data, some of the error maybe disappears a little bit. And one of the things I've sort of kind of left in when I do work with geography is I've sort of started to port in all the other links and codes I need to be able to do other things. So this is the price paid data as I visualize it against its geography, but I can also, through referencing, say, associate that geography to streets, and then aggregate data to give me median or mean or lowest or highest or any form of other information against streets. So aggregation, and therefore the collection of data into geographical areas, be they against a street or be they against an area, is one of those sort of tools that people do. And it means that it allows me to sort of think and use data differently. So something that arrived is, in this case, a point data set and with what would I call an implicit piece of geography. I made explicit, and then I've been able to utilize that to do quite a lot of other things. And once I've got it there, it would allow me to then do maybe some analysis that I wanted to. And for the sake of interest, not because of any particular thing, I just worked out which LSOAs had doubled median house value in the last 10 years, 2008 to 2018, which again is one of those things that you wouldn't be able to do against that data as Land Registry deliver it, but you can do if you start and think about the use of that data. So that was kind of me just getting you to grips with Ordnance Survey data, what it does, how it might be used, how it might work for you. Hopefully that's the sort of thing that some of you have done. Have people here used Ordnance Survey data? Are any of you using geography? I know CDRC do some great stuff with geography, as do others. So people use geography to do a range of things. What I've tended to find they do is they want to know what they own, they want to know where something is, and they also want to know sort of what it's like. So that brings them to asking questions of geography. They're trying to say, I want to know something about the somewhere, the somewhat. I want to know where something is. I want to know how old something is, its condition. There's a range of questions that people want to ask of maps, and they're not always there, available and ready for you to do. So the thing to bear in mind is certainly with our data and most other people's geographical data, they have schemas. And the schema is what you go and capture. So with the Ordnance Survey data, we have a data schema, and the data schema is in effect a capture spec. And you often misinterpret what the capture spec is when you look at a map. So you probably look at a map and you'll see houses or offices or some other things because you use real world words to describe what you're seeing. Whereas in actual facts, the schema will describe you're capturing pieces of building with a similar roof height, which means that when you come to do something with it, you maybe create another piece of building if there's a sticky out porch at the front, or another piece of building if there's some covered overhang. And these things will matter, and I'll come on to explain why they might matter later. So the data will have a schema, and the schema will describe what you capture, and it'll also describe what you don't capture. So in our data, there's lots of things missing that you might want. We don't capture bus stops. That might be something someone wants. And if you want to capture that and put it into your data, in our case, the capture spec and the currency of the data is 3 years. So it could take us 3 years to, in effect, run through new content. So we've been trying to put in non-permanent caravan dwellings that are semi-permanent. So those caravan sites, historically, we didn't capture caravan sites because we felt that they could be moved away. Someone said, oh no, we like those, people live there. And so we started capturing the ones where people lived and they had addresses. And then when someone said, well no, but we want them all because there may be a flood risk. There may be someone there on holiday, so we had to capture them all. And to do that, in effect, the way we capture data and the way we roll these things through, because there isn't a planning process telling us about the change, means it would take us 3 years to capture that and put it into the data. So we maintain our data on a sort of couple of currencies. One is as things get built, because it's the planning process and they let us know it's happening. And the other is as we see them as we fly aerial photography, which is a rolling 3-year process. So you have to think about the spec of the data you're using when you come to use it. Now, once you've got that spec, as I was saying, you kind of look at things and you sort of say, well, it's not really delivering what I want, these bits of building. They're not really describing the things I want to use. And the most common questions we're sort of asked about in terms of use case is to do with the population who lives somewhere, who works somewhere, who's vulnerable to a flood risk. You know, it's the sort of data that relates to places that people live and work. And that's not really in that mapping data. And you sort of have to work out how to compile it. So I've been mixing some addressing data with some mapping data to sort of, you possibly can't see that, but it sort of gives me a sort of a use breakdown of property, and I kind of can say, oh, this is commercial use, this is a single commercial use, this is a multi-commercial use, this is a mixed use, so there's residential and commercial in the same, this is a flat, a terrace, an end terrace, and that becomes useful for a question you might ask. So I was asked not too long ago, could you identify in London all the low-rise single-use commercial buildings that may be occupying valuable land that could become housing. And if you have a schema that allows you to do that, you can. And if you have a schema that sort of just captures some flat-roofed building and you don't know what's there, you can't. So the data schema and the things that you have in your data matter a lot to its use, and they matter how you can extract information from it. With our data, we've been trying to work out not only taking statistics into the data and aggregating and looking at them against it, but also how we could maybe use the data that we know about to create land use classifications to take statistics out. So instead of thinking of maps just as maps, can we break the information down into things like this? So this is some work we did for Hampshire 2050. And they wanted to understand Hampshire, they wanted to understand what made it special, but they also wanted to break it down into the districts that were part of it and say, well, are they all the same and what's the nature of them? So we were looking at the natural environment, and these lines represent how the area of the place is, and then the proportion that is different land use classifications. So you could see if you looked at that Gosport isn't very large and doesn't have as much natural environment as some other places, but conversely, it does have quite a good proportion of the built environment in Hampshire. So it's a way of using maps to sort of create statistics or to create metrics that are useful to do something else. And we took this a little bit further, doing some work with Greater Manchester Council, when we in effect created deciles of all the feature classes within Ordnance Survey master map. So we could sort of look at the data and say, right, this is the district with in the first decile in terms of residential garden. This is a district which has LSOA, level, has the least amount of something or has more warehousing, because they were trying to answer the question, what makes places attractive and how can you improve them? And before you answer those questions, you sort of need to know what's there now and be able to compare them to the places that are attractive and where people maybe did want to live. And what they found when they looked at Manchester was Manchester didn't have a housing crisis, i.e. they said you could afford to buy housing at 3 times average earnings in and around the Manchester area, but you couldn't do it in all the places you'd like to live. You could only do it in the places which had lower quality neighbourhoods. And why was that, and how could they improve them? And this sort of work allows you to sort of, I'll zoom in a little, allows you to sort of see how you could use mapping data differently to give you statistical output that blends well with other intelligence. Now, I was going to tell you a little bit of a story about some work I did for MHCLG, but it's become used by ONS. And this was identifying new build housing. And as I said before, we make map, and lots of other people are a little bit like this. They have always done something they've always done, and it's for a purpose. So in effect, we make maps, and we keep the maps up to date, and everyone who wanted to have a map to do some planning work or some other impact analysis had that kind of data. But as we've made things sort of more analytical, we start to ask questions. And the questions that you sort of get asked is, where are the new builds? And it's not very obvious for anyone's data how many properties are being built and where they are. And I was sort of speculating you could determine that through looking at the rate of new build data in our data, and you could also use that to determine population change. So that was the population density based on the 2011 census, and you'll see a very minor adjustment. That was huge there. And then that's the sort of zoom in of that population change, the areas that have got expanded populations. And I speculate this isn't the population, this is my estimate of what the population would likely be if you looked at where that new build housing is. So that's the new build housing that's causing a change in the population. And what we found when we did some regression analysis of the actual mid-year census forecast and the amount of new build going in was that there was a very, very strong correlation. It was 0.99 correlation of housing, new housing to population. And we estimated the housing just proportionality with the original numbers of housing before the change, and therefore we upped the the population by the same amount relative to the housing density that was there beforehand. We didn't have anything beyond that. So you could use housing to say something had changed, but that meant that you wanted to pull that new housing from our data. And that's not very easy because it comes back to that thing called a specification. So this is Ordnance Survey's view of new build housing in Mastermap, and this is the custodian in Lichfield saying that new build housing exists in Lichfield since 2015. And neither of those are true. That's a traditional area that's undergone lots of redevelopment and the properties have become more than 50% bigger, whereas that's a custodian playing around with the entry date of his addresses. So those things create error, and you're trying to pull those errors out. So I did some analysis where I sort of tried to work out how you could capture what was new build by sort of aggregating and looking at all the sources of data that are available to you. So I kind of looked at the topography layer and the addressing and did some analysis where I sort of created clusters and tried to create areas that were all new, those individual infills where someone's expanded a house and broken the schema rules of our data I could sort of overcome. And I could also then sort of start to chart the sort of uptake of new mail addresses, the uptake of new valuation office, council tax records and other things, and sort of compile a view of a new build estate, which I could then sort of push into the land registry data and do some nasty analysis on and sort of create a site. And within that site, I could then sort of create statistics about how many new properties are delivered and what they were like. So rushing forward a bit, I could classify that data based on those best sources. And I did kind of, on the left, you'll see these all look different colours based on whether they've been sold as new build, or the land was sold for a social housing project as new, or it got a new PAF address. Or I had to really do quite a lot of work to aggregate lots of data sources to find a sort of reliable view of what was new, which was sort of counterintuitive. You'd expect that you could just sort of look something up once and it would be right, but you can't. So you end up having to do data aggregation, but spatial records aggregation is quite a good way of mixing and interpreting that. And what I sort of found then, I could create these national statistics, and we use that to sort of not only say what was happening, but also the proportion and type of property that was being built. And we did some analysis where we were looking at the sort of amount and rate of property that went in. And you could also sort of start to look at that home ownership type. So you could see whether it had been built to be sold or whether it had been built as some form of social housing. And you could add the tenure to the data, and you could start to sort of aggregate and create a picture. And so I took that to its logical conclusion, I thought, and then started to see, well, could I look at the dwelling types across the whole city? And so this map here, everything that's green is an HMO. Everything that's blue is social housing. The brown stuff is sort of owner occupation, but the red stuff is owner occupation that's owned but rented. And that was just by aggregating data from a variety of sources, from the land registry, from EPC, from the HMO registers, and sort of mulling it all together and pulling out what I wanted. And the places where this sort of went wrong was when I tried to get some sense of what was the definition of a new property. So I did all this work, which was fine, and mine was the result of a method. It wasn't the answer to how much new build had been built. It was a result of a method that looked at ascribing things to be new in some form of mix of addressing or mapping or other things. But it raised a question that I haven't yet got an answer from the policy people I did it for, which was what was the definition of a new property? So I bring up Queen's Road in Coventry, and if you could read that little sign, it would say tenancies available for students in the 2019-20 era. And I'll ask you this simple question. How many properties do you think exist in these particular, what look like single dwelling things? And that has 20 flats in it, which was a conversion. This one has 5 apartments. There's 22 bedsits next door. There's 16 in single self-contained units there, and there's 24 in that one and 14 in that one. So it raises a question. Are they all new? Have they added, really, I can't do the maths quickly enough, but nearly 100 new builds in that street in Coventry? And from when you see those statistics that say Coventry has built 4,000 new properties this year, I would ask you to be slightly sceptical. It does raise a question, which is then how can you use that data to find these people who may be in split things? And I just did a bit of work where I looked at the difference between the number of properties and the type and number of tenures within the land registry data. So I could start to break this down into things where things seem to have been built to be subdivided and sold, so the number of addresses and the number of titles seem to match. And the places where, in blue, there's a large number of properties or addressed items, but only a single ownership. So they seem to be created to rent, or there's some form of splitting or bed-sitting of properties. So there is analysis you can do when you get down to it. I'm looking at the time, and I'm just going to skip through this, but it was just a quick case study. Unfortunately, you can see it in the notes, looking at the tram lines in Birmingham and the effects they had on house prices. I will leave this up, though, which shows that a lot of new property has created a wealth of increase in the value of flats, but hasn't really impacted detached, semi-detached and terraced houses. But if you build new, and we've seen this in several places, if you build new travel infrastructure, you will create an environment in which people want to live, particularly in flats within sort of walking distances of stations. Right. I am going to just, for my last bit, say, and I'm glad I put this in because Joel's present. Is Joel still here? No, oh well, this would have been for him. The rest of you who know him, just tell him it was brilliant and he really missed out. So this was fascinating. I did look at the new build property in, and this is just Bristol picked at random. But as I said before, I've geocoded, so this is all the new build property, and I've geocoded all the EPC data. Now, the EPC data is the energy performance certificate that you need if you rent or sell or buy a property. And you can sort of see that the cost here of heating your home is very low if you're a dark green colour and very high if you're in the browns and dark browns. And you'll see that new build property tends to have an impact on the cost of heating. So you can see that there's a relationship between heating and income. And the only place where you sort of break the fact that richer people spend more heating homes is in the new build areas. But you can also begin to see the areas where maybe there's a lack of income but a high cost of housing, to heat housing. So I do think that using spatial data, if you do the right kind of analysis, leads you to find new things. I think you could use this type of work to find and locate places you could approach the council, as Joel was trying to do, for that kind of thing. So there seems to be a lot to be said for that. So that was me. I hope that was interesting. The one other thing I would add is the places where I've had the most trouble and the most failure was post-Grenfell, trying to analyse where there were large tower blocks with social housing and large numbers of residents. And particularly where they had cladding. And some of the problems we ran into was the contextualisation of information. And in the planning, when we were trying to trawl through and pull out the planning information, the word cladding was not associated with aluminium cladding. It could be associated with bamboo cladding. It could be associated with anything. So the context of information and how you used it, combined with the fact that you were trying to discover if something was a tall build tower block by examining building heights and address seeds would be in porches as opposed to the buildings, created this tremendous use problem. And the only thing I could think of, if you don't think about what you're trying to do before you do it, you'll create a real large problem trying to get the information out of data sources that you aggregate based on certainly spatial geography or contextual use of attribution. But otherwise, thank you.
Thank you very much. If I quite like when a talk references right back to the first two. I know the Grenfell Tower problem is one of the motivating factors for the Digital Built Britain project as well. It gets referred to as one of the sense checks we have. I'm also slightly concerned. because I have a little bit of a connection with local authority and on a planning committee, how it's the new build houses that cost more to heat.
No, cost less.
Because
Leased.
pardon?
They're leased. They're really efficient.
Yeah. Oh, the least. Oh,
Least.
sorry. Oh, that's better.
No, new
I'm
build
glad of
housing
that.
is
I'm glad
really
I clarified
efficient.
that. That's the other thing about data. You can easily get it exactly the opposite way around. Is there one question anybody wants to put? Andrew.
One of the things I'm really interested in is open data. And one of the worries I have is around the modifiable aerial unit problem. Is that the level of aggregation affects the measures that are put out. And I see a lot of stuff at LSOA. You've got all of the toys in the toy box. Do you have any advice for people on the unit by which you aggregate and how people can be just aware of how that can then bias your interpretation?
So everything I've seen is if you can aggregate, if you can avoid aggregation at the point you're doing the data collection, but in effect do the association and then aggregate after the event, you get so much better outcome. I would say that though, because I can access all this data that allows me to do that. The thing I've noticed when I look at otherwise at data sets is certainly if you're trying to do things in terms of spatial context, even by the time you've got to LSOA, you are amalgamating a large mix of different property types, different property ages, all sorts of things. I know you've got dwelling age, haven't you, in MSOA and CDRC, I think it's available. And if you look at that, it lists, amongst that, and you see that it's just impossible to sort of reconcile individual property dwelling ages or even sensible street-level dwelling ages from aggregated data. You can't do it that way, so it makes me wonder what the use is going the other way, whereas some data is nice and conformant and works quite well. I guess if you can work at that really accurate level, you do reap the reward, but it does add a little bit of time at the beginning.